Let us discuss one more example. Again, here we will be applying KVL. So the problem statement is, what is current flowing through 50 volt? So in this circuit, you can see 50 volt is here, 5 ohm resistor in series, then one current source, parallel resistor 2 ohm, and then 3 ohm and 10 volt. So first of all, we will transform current source into voltage source. So this 10 ampere and 2 ohm. So I into R, that is 10 into 2, 20 volt voltage source, and then in series with 2 ohm. Now this is 50 volt with 5 ohm. This is 10 volt with 3 ohm. What we want to find out is current flowing through this particular. So we will assume two currents like I1 in first loop, I2 in second loop. Ultimately, we want I1, that is through 50 ohm. So first loop equation we will write as, just you can see here, 5 into I1 plus I1 minus I2 into 2 plus 20, and then this minus 50. So either you can like start with this 5 ohm resistor and then you can write the equation. This is plus minus battery taken plus. So therefore minus plus battery we have to take minus. So that's why the equation will look like this. Otherwise you can start with 50. So 50 minus 5 I1 minus 2 into bracket I1 minus I2 and plus 20. So like that also you can write the equation, but this way is also allowed. So here we will just simplify it a little bit. 2I2, this is 2I2 and 5I1 plus this 2I1, so total 7I1 equal to 30. This is first equation. For loop 2 we will write, so it is, say, from 3 ohm, this is independent, so therefore 3 into I2 first term plus this battery 10 volt, then this battery, this plus minus we have taken plus, therefore this minus plus we will take minus, and plus I2 minus I1 into 2 ohm. So if we simplify this little bit, minus 2 I1, this 2 into I1 term, and I2 term is I2 into 2 and 3 I2. So total 5 I2 equal to 10 minus 20, that is minus 10. To the other side it will become plus 10. So these are the two equations. Instead of solving it by a substitution method, we will just use this matrix method of two simultaneous equations when we want to solve. So for that, first of all, we'll write the matrix and then we'll just write it into the determinant form. So this is first equation. So the I1 coefficient is 7. So here 7. From second equation, I1 coefficient is minus 2. From first equation, I2 coefficient is minus 2, and from second equation, I2 coefficient is 5, and then I1, I2, and the constant part, that is 30 from first equation and 10 from second equation. So first step is we want to find out delta. So this will be cross multiplication, 7 into 5 minus 2 into minus 2. So this is 7 into 5 minus 2 into minus 2. So resultant will be 35 minus 4, that is 31. Delta 1 we want to calculate. So at that time, column of I1 corresponding to I1 elements is to be replaced by this constant elements. So 7 and minus 2 we have to just replace by 30 and 10. So 30 and 10. And now again with cross multiplication, solve this determinant. So 30 into 5 minus 10 into minus 2. So this total will be 150 plus 20, that is 170. And the third determinant, that is delta 2. So for this reason, this I2 column should be replaced by 30 and 10. So 7 minus 2 first column as it is from this determinant, and second column is replaced by this constant, since we want to find out for delta 2, that is for I2. So that will be again 7 into 10 minus 2 into 30. So resultant will be 70 plus 60, that is equal to 130. And therefore I2 is delta 2 divided by delta, and I1 is delta 1 divided by delta. So here it is coming out to be 130 divided by 31, 4.19, and this is coming 170 divided by 31, that is 5.48. And this I1 is current flowing through this 50 volt battery. So our expected answer is current flowing through 50 volt will be 5.48 ampere.